Hello, thank you for checking out Mr. Ware's videos. And today we're going to talk about half-life and what it means and how to solve problems that's asking about half-life. So let's take a look. Okay, so what does half-life mean? So here's a real-world example. Uh, it's showing you the concentration of a drug that's in your bloodstream and the hours that it's been given. So after so many hours, it has a concentration of your bloodstream. So for instance, at 0 hours, it's at 100. At 3 hours, it's at 50%. Okay. And so it went to half in about 3 hours. Okay. The half-life of a drug is the time required for the concentration of the active ingredient to be reduced to 1/2. Okay. All right. So that's basically how half-life works. How many times does the total amount goes down by a half? So let's take a look at a more clear definition and go from there. Okay, so a common application of exponential decay is half-life. The half-life of a substance is the time it takes for 1/2 of the substance to decay into another substance. Okay, let's go over the formula. Okay, the formula of a half-life is A, which is your total amount, is equal to P times 0.5, which is 1/2, raised to the T. Okay, now there's going to be two different times involved with T, and I'm going to go over that in a second. All right, so where A is the amount, the final amount, and P is the original amount, and T is the number of half-lives in a given time period. Okay, so let's take a look. So here's an example. A new car is purchased for $18,000, and over time it depreciates by 1/2 every 4 years. What is the value of the car 17 years after it was purchased to the nearest $100? Now, you've got two variables here, P for the principal and T for the time. Now, the time is going to be in a fraction. Now, this is the very important part. Most important part is to remember. Every time you see for 1/2 every, whatever number that is, that's going to be in your denominator or go in the bottom of your fraction. So I'm going to show you that in an example in a minute. So let's take a look here. So first I'm just going to write down the principal, 18,000, right? And then the time is going to be that every part, every 4. And see, this T is going to be a fraction, okay? So it's 4, every 4, and wherever you see every, that's going to go in your denominator or the bottom of the fraction, okay? And the top part of the fraction is going to be the total number of years there, 17 years. Okay, so the every goes in the denominator. The total number of years, the other part of the years is going to go in the numerator up top. Okay, so now we're going to take that same formula, A is equal to P times 0.5, and we're just going to plug in those values. So 18,000 for P, 0.5 from the formula, and it's raised to 17/4. And now we got to do is just type it in the calculator. 18,000 times 0.5 raised to, open parentheses, 17 divided by 4, close parentheses. All right, once you type that in the calculator, you get this big long number here. And on this case, it wants to round to the nearest $100. Okay, $100. So we go all the way to this 9 right here. Look to the right, and it's a 4. So it's not 5 or more, it's 4 or less. So we round down to $900. All right, let's take a look at another example. Now it's important to remember you don't want to memorize where they are in the word problem, where the numbers are. You want to really know what they mean and put the right thing in the right spot. Okay? So here it says element X is radioactive isotope such that every 21 years, its mass decreased by half, given the initial mass of a sample of element X is 40 grams. How much of the element would remain after 9 years to the nearest whole number? So we're going to start out the beginning amount. The beginning amount is 40 grams. Okay, so we start off with 40 grams. Alright, so now we're going to do this fraction for t. Remember that every part goes in the denominator in the bottom. So we got 21. And then the total number of years here, 91. Now, notice how in the last problem, the bigger number was on top and the smaller number was on bottom. You don't remember that. You want to remember that the every part goes in the denominator. Okay? And the total years we're looking here is 9 years. So we're going to put that in the every 21 years. So it doesn't even get to a full half-life on this because it takes 21 years to get there. But they still want to know what is the decay at 9 years. So let's take a look here. We're going to plug into the formula. A is equal to P times 0.5 raised to the T. We got A is equal to 40 times 0.5 raised to the 9 over 21. That's the T. Plug in the 40 and the 9 over 21. And then we're just typing in the calculator. 40 times 0.5 raised to the 9 divided by 21. Make sure this second part is in parentheses here. We get this long decimal. And in this case, they want us to round to the nearest whole number. Okay, which is this 9 here. So we look to the right. 0.7 is 5 or higher. So we round up to 30. And that's it. That is rounding to the nearest, I'm sorry, not rounding. That is finding half-life. I want to thank you for checking out Mr. Ware's videos. Have a nice day.